This is the Combined Science Chemistry O-Level 10-year series question. This question is from 2005, paper 3, A5. Okay, germanium Ge is extracted from germanium 4 oxide by heating with hydrogen. This is the unbalanced chemical equation for the reaction. So you have to balance, for 1A you have to balance the above chemical equation. So GeO2 to become Ge, and then on the right hand side there is 1 oxygen, on the left hand side there are 2. So naturally you put a 2 here. When you put a 2, oxygen is balanced. How about hydrogen? Hydrogen, there will be 4 hydrogen on the right hand side, so on the left hand side there should be 4 hydrogen as well. Okay, for 1B, during this reaction, hydrogen removes oxygen from germanium 4 oxide. So you remove oxygen. What is the name given to the change of germanium 4 oxide to germanium? Remove oxygen means loss of oxygen. Loss of oxygen is called reduction. Gain of oxygen is called oxidation. So the answer for this question should be reduction. Very straightforward. Now for part C, the following relative atomic masses should be used for these calculations. Calculate the percentage by mass of germanium in germanium 4 oxide. So germanium 4 oxide is actually GeO2. So this is GeO2, and germanium of course is Ge. So you have to find the percentage by mass of germanium in germanium 4 oxide. Now we know already the AR of germanium already given, 73. How about the MR of germanium 4 oxide? That would be 73 plus 16 times 2, and that would give you 105. So percentage of mass of germanium. So what would be the percentage by mass? So percentage by mass would be 73 over the whole thing, 105 times 100%. And that would give you 69.5%. Now always remember, the final answer must always have 3SF. Final answer must have 3SF. Now is this question. Okay, calculate the smallest mass of germanium 4 oxide needed to produce 300 grams of germanium by this reaction. So you want to produce 300 grams of germanium. And what would be the mass of germanium 4 oxide? Okay, so for this question there are actually two ways of solving it. You can either use a mole ratio or mass ratio. If you use mole ratio, then you have to change 300 gram to number of mole. Okay, if you use mass ratio, actually it is slightly easier. So let's use mass ratio. So the working would be mass ratio. You must write down what ratio you are talking about. Mass ratio of germanium 4 oxide and germanium. What would be the mass of 1 mole of what would be the mass of 1 mole of germanium 4 oxide? So that would be the MR of GeO2, which is 105. So 105 gram. How about here? So based on the chemical equation, it is 1 mole, 1 mole. So the mass of 1 mole is 105 gram. What would be the mass of 1 mole of germanium? That would be 73. Mass of 1 mole. Okay, and now, so this is a mass ratio based on the chemical equation. And now you have how many grams of germanium? you have 300 gram of germanium. So what would be the mass of germanium 4 oxide needed? So this is like cross multiply. Okay, this one multiply this one equals to this one multiply this one. Or you can also do it in such a way that you can also do it like this. Your x would be 73 300 times 105. Okay, it's the same. You get 432 gram. So therefore, mass of GeO2 432 gram. That would do it. So for this question, you can use either mass ratio or mole ratio. If you use a mole ratio, you have to change 300 gram to number of mole first. It's the same thing. After you find the number of mole of GeO2 needed, you have to change it back to mass because the question asks mass. So therefore, it is slightly easier if you use mass ratio. If you use mass ratio, so the two chemicals we are talking about is these two. So you have to ask yourself, based on the chemical equation, what is the mass of 1 mole of GeO2 to 1 mole of Ge? So the mass ratio is 105 gram. How do you get this 105 gram? So this is the mass of 1 mole of GeO2. Mass of 1 mole of GeO2 is the mole times the MR. MR is 105. Mole is 1 mole. So 1 times 105 will give you 105 gram. How about for Ge? Same thing. For the mass of Ge, you have to mass of Ge would be the number of mole, which is 1. Okay, based on the chemical equation, times the AR, which is 73. So 1 times 73 is 73 gram. So this is a mass ratio based on the chemical equation. The first row is always the mass ratio or the mole ratio based on the chemical equation. Then after that, the second row here would be the information given by the question, which in this case it says 300 gram of germanium. So 300 gram, and you have to find out what would be the mass of germanium 4 oxide. So based on this, x would be 300 over 73 times 105. Why is it 300 over 73? You can also cross multiply like this and find out what is the x. So that would give you the answer of 432 gram. Then write down, answer the question, because the question asks you mass of germanium 4 oxide. So equals to 432 gram. Remember, the final answer must be in 3SF. The next question is from O-Level Combined Science Chemistry 2007, paper 3, A5. Okay, an ore contains 10% of mass of the mineral wolframite. An ore basically is a compound. For example, iron 3 oxide. I mean, an ore, it's a compound, iron 3 oxide. That is a iron ore. So ore contains 10% by mass of a mineral called wolframite. Wolframite contains tungsten W and has the formula. So you have something ore, and 10% of this ore is made up of this mineral called wolframite. And wolframite contains tungsten and has the formula. So this is actually the formula for wolframite. So this wolframite, the formula is this. So this is the formula for wolframite. And of course, this wolframite inside there is tungsten, which is W. Calculate the mass of wolframite in 10 tons of the ore. If you have 10 tons of the ore, you have to calculate the mass of the wolframite. 10%, that means out of this 10 ton, 10% of it is wolframite. So very simple. So the mass is, the mass of wolframite is 10%, which is 10 over 100. 10%, the meaning of 10% is 10 over 100 times 10 tons. And that would give you 1 ton. Finish. Okay, for part 2, calculate the mass of tungsten in 10 tons of the ore. In 10 tons of the ore, there is 1 ton of wolframite. And what would be the mass of tungsten? So this wolframite is this. What would be the mass of tungsten? That means W. In this 1 ton of wolframite. So you have to find, there will be this W. So you have to find the percentage composition of W in the wolframite. Wolframite, I have 1 ton. So out of this 1 ton of wolframite, what would be the mass of the tungsten? So you have to find the percentage composition of tungsten, of W, in wolframite. So first of all, in order to do that, to find the percentage composition of tungsten in wolframite, you have to find the MR of wolframite. So the MR of wolframite, which is FeMnWO4, and this one is Fe 56 plus Mn 55 plus W 184 plus oxygen, they are 4, so 16 times 4, and that would give you 359. And what would be the mass of tungsten? So mass of tungsten would be the percentage composition of tungsten in wolframite, which is 184, because in 1 mole of wolframite there is only 1 mole of tungsten. Okay, and the MR and the AR for tungsten is 184. So 184 over 359 times 1 ton. What is this 1 ton? This 1 ton is the 1 ton of wolframite. So this is the percentage composition of tungsten in wolframite. This is the mass of the wolframite. And by multiplying this, we can get the mass of tungsten in 1 ton of wolframite, which is 0.513 ton. So remember, in 10 tons of the ore, there is only 1 ton of the wolframite. So we already found it here. That is why this 1 ton and this 1 ton are the same. So this question, by writing it in this manner, you can tell very clearly what is the relationship between ore, wolframite, and tungsten. So wolframite is in the ore. 10% of the ore consists of wolframite, and in the wolframite there is tungsten inside. In industry, wolframite is changed into tungsten 6 oxide, WO3. Metallic tungsten is formed by heating this oxide in hydrogen gas. So we can get tungsten by heating tungsten 6 oxide with hydrogen. Tungsten 6 oxide is changed to tungsten by reaction with hydrogen. What is the name given to this type of reaction, this type of change? So WO3 to W. So obviously this is a removal of oxygen or loss of oxygen. Loss of oxygen is called reduction. Gain of oxygen is called oxidation. Reduction. Now calculate the mass of tungsten that could be formed from 20 tons of tungsten 6 oxide. Okay, mass of tungsten, okay, that could be formed from 20 tons of tungsten 6 oxide. So I have 20 tons of tungsten 6 oxide here. 20 tons. What would be the mass of tungsten that could be formed? What would be the mass? So again, we are talking about mass, so it's better to look at the mass ratio. You can also use mole ratio, but then that would mean that you have to change 20 tons to the number of mole. Okay, so it's easier to use mass ratio. Okay, so before you use mass ratio, what would be the MR of WO3? You have to find out what is the MR of WO3, which is W is 184, O3 16 times 3, and that would give you 232. MR of WO3 is 232. Then we can look at the mass ratio. Mass ratio of what? It's always two chemical. Mass ratio of WO3 and W. WO3 and W. What is the mass ratio? The first row is always from the chemical equation. So in this case, what is the mass of 1 mole of WO3? The MR is 232. So the mass is number of mole times the MR, which is 1 times 232, which is 232 gram. How about the mass of 1 mole of W? Mass of 1 mole of W is actually the same as the AR, which is 184. So the first row is from the balanced chemical equation, 232 to 184. How about now? Now I have 20 tons of tungsten. 20 tons of tungsten. What would be this? You can see gram, ton, ton. So whatever number, whatever answer that I get for X, that would be in terms of ton. You don't have to change the ton to kilogram to gram. If you want to, you can also do that. 1 ton is 1,000 kilogram. 1 kilogram is 1,000 gram. So if you do that, you can also get the final answer, but then your number would be in gram, and that would be a huge number. So actually you don't have to change it to gram or kilogram, because the question only asks you about mass. The question didn't ask mass in what unit. Okay, so remember gram, ton. Cannot be gram, ton, or kilogram, gram, and then kilogram or ton, kilogram. Cannot. Okay, so it's by row. By row, the unit must be the same. Gram, ton. So by solving X, I can find out that X is 232 20 times 184, and that would give you 15.9 tons. Okay, so just therefore mass of tungsten (15.9 tons), and remember it must be in 3SF. 15.9 tons. Alright? Okay, next question. This one is from 2010, paper 3, A2. So the table describes 2 different solutions. Complete the table. One product, so you have a sulfuric acid, chemical formula, of course it's H2SO4. One product of the reaction with ammonium carbonate. Now, this ammonium carbonate is very interesting. Ammonium carbonate, of course, it is an ammonium salt. It is an ammonium salt. Also, ammonium carbonate is a carbonate. Correct? It is an ammonium salt, it is a carbonate. So, what would be the product form from the reaction between sulfuric acid and ammonium carbonate. So you have to ask yourself, is there a reaction called ammonium salt and acid? Acid and ammonium salt, is there such a reaction? So you try to recall from your acid bases chapter. Acid, ammonium salt. No, you don't have such reaction. How about acid and carbonate? Acid and carbonate, yes. Acid and carbonate, you get carbon dioxide, you get a salt, carbon dioxide, and water. So over here, you can write carbon dioxide, water, or the salt. So what would be the salt? The negative ion of the salt must be from the acid. So the negative ion is sulfate. The positive ion of the salt must be from the carbonate, which is ammonium. So the salt is ammonium carbonate. Ammonium sulfate. So for this one product, you can either write carbon dioxide gas, or water, or ammonium salt. Okay, for this one, ammonium sulfate, carbon dioxide, or water, either one. How about for this chemical formula for sodium hydroxide, NaOH? Okay, then you can ask yourself, this is an alkali. So is there a reaction between alkali and carbonate? Don't have. Alkali and carbonate don't react. How about alkali and ammonium salt? Yes, alkali and ammonium salt, you get ammonia, salt, and water. And the name of the salt would be sodium carbonate. So for here, you can write either ammonia gas, water, or sodium carbonate. Okay? Ammonia gas, water, or sodium carbonate for this. Either one of the three answers, because the question wants one product. Next question, this is 2012, paper 3, A8. Now a solution is made by dissolving 53 grams of sodium carbonate in water and making the volume up to 500 cm cube. Calculate the concentration in gram per dm cube of this solution. So concentration, gram per dm cube, look at the unit. Gram per dm cube. Do you have the mass? Yes, you have the mass 53. Do you have the volume in dm cube? I have the volume in cm cube, so I just change this 500 cm cube to dm cube. Just remember, 1 dm cube is 1000 cm cube. And with that, so what would be the volume? So you can actually write down the volume is 500 cm cube, which is 500 over 1000, which is 0.5 dm cube. And the concentration is mass divided by the volume, 53 gram divided by 0.5 dm cube, and that would give you 106 gram per dm cube. So this is 106. Okay. Okay, for part 2, a solution contains 53 grams of sodium carbonate, Na2CO3 in 2 dm cube. Calculate the concentration in mole per dm cube. So you have to find out how many mole. 53 gram is how many mole, and the dm cube, the volume, already given. So 53 grams, you have to find out how many mole. So in order to find out the mole would be mass over mR. So you have to find out the mR first. What is the mR for Na2CO3? There will be 23 times 2 plus carbon is 12, oxygen is 16 times 3. So the mR is how much? 23 times 2 plus 12 plus 48, 106. the MR is 106, and then the number of mole is the mass 53 divided by the MR, which is 106, and that will give you 0.5 mole. And then after that, what would be the concentration? So the concentration is number of mole 0.5 divided by the volume, which is 2, and that would give you 0.25 mole per dm cube. So 0.25, is that your answer? It should be 3SF, so 0.250 mole per dm cube. Okay, next one. Write the balanced chemical equation for the reaction between sodium carbonate and hydrochloric acid. State symbols are not required. So sodium carbonate, what kind of substance is it? It is a carbonate. Hydrochloric acid, it is an acid. So acid and carbonate, you have to recall, acid and carbonate, you get salt, carbon dioxide, and water. So sodium carbonate, give you already the chemical formula. So it's Na2CO3. Hydrochloric acid, of course, is HCl. And they will give you the salt. What would be the name of the salt? Remember, the name of the salt consists of positive and negative ion. The negative ion of the salt is always from the negative ion of the acid, which is chloride. And the positive ion of the salt is always from the other substance that the acid reacts with. In this case, is sodium. So the name of the salt will be sodium chloride, NaCl, plus carbon dioxide plus water. Then you have to balance it. Obviously, there are 2 Na on the left hand side. On the right hand side, there must be 2 as well. And then how about the Cl? 2 Cl. So this one only 1 Cl. Put a 2. Okay, I think it's already balanced. Yeah. Now, how many mole of sodium carbonate will react with 4 mole of hydrochloric acid? You have 4 mole of hydrochloric acid. How many mole of sodium carbonate? So we look at the mole ratio. Mole ratio of sodium carbonate and hydrochloric acid. Remember, the first row is always from the chemical equation. The first row of numbers is always from the balanced chemical equation. So the mole ratio is 1 mole to 2 mole. 1 mole to 2 mole. And now I have the second row of the chemical ratio. The second row of the ratio is always from the information given by the question. So in this case, 4 mole of hydrochloric acid. 4 mole. See? 2 to 1, 4 to 2. So this one must be 2 mole. So the answer, 2 mole. Very simple. So whatever ratio that you look at, always remember the first row from the chemical equation, from the balanced chemical equation. The second row from the information given in the question. Next question is from 2013, paper 3, A5. A solution of nitric acid HNO3 has a concentration of 126 gram per dm cube. Calculate the relative molecular mass of nitric acid. Relative molecular mass is MR. So what is the MR of HNO3? 1 plus 14 plus 16 times 3. And that will give you 63. Remember, there is no unit. Calculate the concentration of the solution in mole per dm cube. Okay, you are given concentration is mass per dm cube. You have to change it to mole per dm cube. So if you change gram per dm cube to mole per dm cube, it is as if you are changing from gram to mole, because the bottom are the same. Bottom are the same, only top are different. So by changing 126 gram per dm cube to mole per dm cube, it is like changing gram per mole. How do you change from gram per mole? So mole equals to gram divided by mR. Mass divided by mR. So the concentration would be mass which is this one. Okay, changing from here to here is the same thing as changing from mass to mole, which is mass divided by the mR. So in this case is 126 divided by the mR given to you already. Already calculated, 63, and that will give you 2. So the concentration is 2 mole per dm cube. By just looking at the unit, you know how to convert. Next one, magnesium carbonate reacts with nitric acid as follows. How many mole of magnesium carbonate, which is this, reacts with 1 mole of nitric acid? Same thing. This is the mole ratio. So what would be the mole ratio? Mole ratio of magnesium carbonate and nitric acid. Magnesium carbonate, nitric acid. Remember, first row must be from the balanced chemical equation, which is 1 mole to 2 mole. 1 mole to 2 mole. Now 1 mole of nitric acid now is 1 mole. See, 2 is to 1. 1 is to 0.5. Because 2 to change 2 to 1, you have to divide by 2. So divided by 2. So 1 divided by 2 is 0.5. So you get 0.5 mole. Next question, how many moles of magnesium carbonate react with 500 cm cube of 10 mole per dm cube? Now if you look at this one I can change it to dm cube. Okay, 500 cm cube would be 500 divided by 1000, which is 0.5 dm cube. So if you look at this one, dm cube, mole per dm cube, look at the unit. This one I changed it to dm cube already, right? So dm cube times mole per dm cube. Then this dm cube and dm cube will cancel off, leaving us with mole. So by multiplying these two numbers, we can get the number of mole of nitric acid. So what would be the number of mole of HNO3? Is by multiplying these two numbers. It is 0.5 dm cube times 10 mole per dm cube. 10 mole per dm cube. Okay, multiplying it,